Okay, so in a nutshell, we're going to be covering 1.3.2 wired and wireless networks, protocols and layers. In this section, I will cover wired versus wireless, encryption, IP MAC addresses, standards, protocols and layers. So let's look at modes of communication. So wired, let's look at the advantages, disadvantages. A wired network basically is more secure because you need physical access to the cables to get into the network. It's also faster, more stable and less susceptible to interference than wireless. But it does require physical cables to be connected, making it much harder to change or move around. The cables can be a trip hazard and often need building work to install, which is quite annoying. And if you want to add a new device, then you have to have the ability to do so, physically. So there needs to be a socket to add the device to. If there's only 5 sockets in a room and you want 10 devices, you've got to put more sockets in. This is quite annoying. The two main wires used in the wireless wired that we're covering are Ethernet and fibre optic. Ethernet is mostly used in LANs over short distances. The actual cable is called Cat 5, 6, 7, whatever, there's lots of different ones. And it sends data with electrical signals. Okay, it's fast, but nowhere near as fast as fibre optic, which is used in WANs over or large LANs to carry data between switches. We do it here at school. We carry the data from our switch from IT1 to the server using fibre optic, and it uses light to carry the data signals. The reason is that electrical signals, they get what's called attenuation. So over distances, they fade, whereas light tends to go very far, as you can guess from the sun to here. Light travels well. Wireless, the advantages, disadvantages are kind of the opposites of wired. Obviously, the advantage of wireless is that it's portable and it's very easy to set up. Disadvantages are it's vulnerable to hacking, as the radio waves can be intercepted from anywhere. Walls or obstructions will reduce the signal strength, as well as many electrical products will cause interference. And the transfer speeds over Wi-Fi are typically slower than Ethernet connections. So the two wireless connections we're looking at are Wi-Fi and Bluetooth. Wi-Fi is mostly used in LANs to connect computers together. A lot of devices support Wi-Fi and it is faster than Bluetooth. Bluetooth is normally restricted to audio data, and the reason for that is it uses very little power. So that's important with portable devices. It has a very short range and it's generally slower than Wi-Fi. It is slower than Wi-Fi. So let's have a look at this one. It comes up with encryption on this. I don't really know why it brings this up too much in this network bit. We're going to talk about encryption later, but all you need to understand with encryption on networking is that encrypted data cannot be easily read without the correct key or password. So if the data is encrypted on a network, then it's theoretically more safe. That's all you really need to know at this point for encryption. Right, so this is a big one. I'm going to take a quick drink. A lot of people get this wrong. I think it's mostly because they put IP addresses and MAC addresses together, but really, I don't know why they do that. So, an IP address is a unique number given to you when you join a network. In IP4, which is mostly used, it's a 32-bit number. It's normally broken up and represented by 4 8-bit numbers, but essentially it's a 32-bit number. And basically, it's your name on the network, and it can be different each time you join. In your house, if this is your house, your router would actually have 2 IP addresses because it has the IP address of your network in your house and the IP address of its connection to the internet. So IP addresses are given to you when you join a network and they act as your name. They help to transfer data around. Like, so I want to send a message to that computer, I do it by sending it to 192.168.0.5 or whatever. Now, MAC addresses, they're not really linked to IP addresses, they just happen to be in a similar area. They're an address, a unique number, much bigger number. I think it's 128-bit, but I'm not quite sure. I have to look it up. Actually, I could work it out by looking at that thing there. It's quite a big number, maybe even more than that. And it is given to every piece of hardware that can physically join a network. So if you're in a system like your phone, that's got obviously wireless network capabilities built in, then there'll be a MAC address attached to that chip that does the Wi-Fi. Okay, and basically what it allows you to do is something called MAC address filtering. So when I join a network, you can see what the MAC address is of the device that joins the network, and then you could decide whether that device is allowed or not. So for example, I could give my friend the password to my internet at home, take his MAC address of his phone, and even though he has, and then allow that, so he's allowed with the phone, even if he then puts that password on his laptop and comes around my house, it will not be able to connect to the network because I'm filtering the MAC addresses as well. And that's really all the MAC address is really used for. is that. Right, standards. A standard in computing and many things is basically where people agree a set of rules about something, and then if everyone designs their product on hardware or software using that rule, then they should work together. For example, Wi-Fi is a standard in essence. Like, as long as everyone designs their product to do the same sort of things, as long as all Wi-Fi things will be compatible. And that's basically a lot of networking stuff does that. There's different, much more specific standards to do with, like, newer versions of Wi-Fi, ones which you get 5 gigahertz and ones that have different ones. But basically, as long as things conform to a standard, they're compatible with each other. That's the idea behind it. Okay, protocols. Now, a protocol is just a set of rules that determine how data is transmitted between different devices in the same network. It's basically a pre-written design of how we're going to send things. Am I going to send my IP address, then the file name, then the file, things like that. How are we going to send it? Because otherwise, it's just numbers going back and forth between computers. Now, we're looking at lots of protocols, but this is the main one. You don't need to know UDP, so I won't be in any exam, but I just show it to you for comparison. So TCP is often used for communicating over our network. It's often called TCP/IP. It's a collection of protocols, but anyway, all you've got to understand is that TCP/IP's job is about getting the data to the destination. So it divides the messages up into a series of packets, small blocks, and they're sent from source to destination. When it gets there, they're reassembled in the correct order, and it's the IP Internet Protocol's job to ensure the packets get there and to ensure that they're recombined. It also does error checking, and it will do things like it checks if you get the data. Okay? UDP, used for gaming, doesn't do that. It basically sends the data, and the person gets it or not, but it's like, well, I sent it. And that's just to show you comparisons of the different types of protocols. You don't need to know that one. You just need to know TCP/IP. And the main thing you need to know is it breaks the message up into packets. They're reassembled at the other end. It does error checking. That's basically it. Right, so now we're going to look at some of the more common protocols, okay, which is to do with how the data is structured. So don't forget that this TCP/IP is to do with how the data gets to destination. So how does the data get there? But these are talking about how is the data structured inside that. So we're going to look at emails. There's two types. One is to do with web pages, and one is to do with programs. So if I was to access my email through Office 365 online, then it's going to use the IMAP protocol to send and receive emails. That does both of them. Okay, so that's the protocol for online email. For the offline email, which means using Outlook, obviously you've still got to have the internet to get the email, but the point is it's a program. It's not done on a web page. It's an installed program. It uses POP3 is the name of it really, to receive incoming emails, and SMTP to send incoming emails. The main difference between these two things are that with these ones, you download the email to your computer, and with these ones, you don't. Okay, that's accessed via a web page on its own. Now, the benefits of this one is that if you've downloaded it and the internet's gone, then if I load up Outlook, even if I unplug myself from the wireless, I'll still be able to read the emails that I had before. And it's probably a little bit faster once they've downloaded, because obviously they're on my computer. But the negative is that I've got to have this program installed on every computer I want to check my emails. Whereas obviously here I can just access the web and check my emails. Right, so files. File transfer protocol is just a protocol designed to send files. That's all you need to know. And then HTTP is the protocol for web pages, and the S version is the encrypted secure version. All you've got to do is know what those mean. I know it's a bit boring, but there you go. That's what you've got to do. And that's that. Lastly but not least, you've got a thing called layering. You don't need to understand too much about layering, but what you've got to understand is layering. If I actually go up to, that's why I stole the nice network layers. Let's do the 4 layers method. Right, if I show you, there's normally a 4 model. It's really a conceptual idea, so there's different models. But basically, let's click on this and get this up. There are 4 layers that are normally talked about, but there are different models, okay? It's an ideology, not a real thing. The idea behind layers are that if you break the task of sending network stuff around in different layers, what you can do is you can change one layer and it won't affect the rest. So the application is to do with the applications like Google Chrome, whatever programs using, whatever. So the application, Edge or whatever, doesn't care about how it gets doesn't care about what these do. It just asks for the web page, and these things sort it out. So the idea behind it is that if you were to improve a layer or take a layer out and improve it and put it back in, these don't notice anything's happened. They just carry on. They don't need to be changed. So if you want to improve, change, for example, here is to do with how you're connected to the network. So this is to do with wireless or Ethernet. So your web browser doesn't care about whether you're connected wirelessly or wired. It is part of the application layer. It focuses on its bit. And that's the concept of layers, really. You don't need to know much more than that. You need to understand that the whole point of them is that you can break the task down into small parts, and if you change or improve one of the parts, the others don't need to know about it, and it's fine. That's basically the gist of it.